Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling the ninth question from the King David High School preliminary examination, which was written in the year of 2023. Please do expect a total number of 12 videos since the question paper had 12 questions in total. That simply means each and every question will have its own video. And please, guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and, most importantly, your final examination. So please, guys, do help us grow the channel by just subscribing. And yes, guys, we are still doing mathematics paper 1, and yes, it is an IEP examination. Okay, we are told to consider the digits 3, 4, 7, 8, and 9. We are being asked how many 5-digit codes can be repeated with no repetition. We have 5 digits to choose from, so the answer is just 5 factorial. Are you together? So 5 factorial, I believe, is 120. Let me confirm. 5. Yeah, it's just equal to 120, so there will just be 120 codes. 120 codes that can be created with no repetition. Okay, and then now we are being asked that how many 4-digit numbers greater than 5,000 that can be created with no repetition. I have a 5-digit number. I must choose from numbers 3, 4, 7, 3, 4, 7, 8, and 9. I must have a 4-digit number, guys. I'm choosing from these 5 numbers. So the only numbers that can be chosen here to be at the first spot, that's 7, 8, or 9. Because if I choose any 3 or 4, I'll simply get a 4-digit number which is less than 5,000. Okay, so whenever we choose 7 to be over there, I still have 4 numbers to choose from over there. Ne? So the final answer will simply be 4 factorial if ever I choose to use 7. Are you together? And then if I choose to use 8, I'll still have 4 factorial options as well, because I have 4 numbers to choose from to occupy these 3 spaces. And even if I use 9, I'll still have 4 factorial choices. So therefore, the final answer will be 4 factorial plus another 4 factorial and another 4 factorial. This will just give me 3 times 4 factorial. And then that will just give me 3 times 4 factorial. There will be just 72 4-digit numbers. 72 4-digit numbers that can be created which are greater than 5,000. Okay, how many 5-digit codes can be created which must start with a 4 and must end with a 7, and repetition is allowed? Okay, 1, 2, 3, 4. All I know is that, guys, I need to have a 4 there and a 7 over there. Are you together, guys? I can only change numbers for these 3 in the middle. But remember that, guys, repetition can be allowed. Are you together? So you can simply have a 4, a 4, a 4, and a 7, or a 7, 7, 7, and a 4, like that. Ne? Just know that for this spot over there, for that spot over there, you have 5 choices to choose from. Over here, you still have 5 choices to choose from, and over there, you still have 5 choices to choose from. So the total number of choices is just going to multiply over there. So the answer will just be 125. Or you can just simply say or you can say 1 multiplied by 5 multiplied by 5 and another 5 multiplied by 1. You'll simply get 125. Why do I have ones there, guys, at the at the beginning and at the end, because I know the values which should be there. Are you together? There's only one option that will occupy this position, and there's only one option to occupy that position over there. That's why I have the ones there. Ne? Okay, and then I'm told that events M and N are independent. Events M and N are independent. Okay, what do we know? So they want us to determine the value of x and fill in the missing values in the table. The probability of not M is 0.2. That means the probability of M will be 0.8. Why? Because the complement of M is 0.2. I know that the probability of M plus the probability of not M should be equal to 1. By just applying this equation, I can simplify the probability of M, ne? And I'll end up finding 0.8. Okay, the probability of M is 0.8, and there is M over there, ne? So I know that the probability of M is equal to 0.8. But how do I find the probability? It's just the number of elements in M divided by the sample space. This is just 0.8. Are we together? I do not know the number of elements in M, but I know my sample space is always there. That's 150 is equal to 0.8. So therefore the number of elements in M is just 0.8 multiplied by 150. 0.8 times 150, I'll simply get 120. So I know that's okay. Over there, I have a total number of 120. Are we together? And then that means for not M, I'll simply have 30, because 120 plus 30 should give me 150. Okay, and then what else do I know? Remember that, guys, I was told that events M and N are what? Are independent. Are you together? Events M and N are independent. That means the probability of M multiplied by the probability of N is equal to the probability of M and N. Are you together? The probability of M is just 120 all over 150 times the probability of N. How can you find the probability of N? Let's check. Oh, we are given the probability of N. That's 0.7, right? So that's 120 over 150 multiplied by 0.7. This is equal to the probability of M and N. That's the number of the number of elements in the intersection of both M and N, which is X divided by 150. Are you together? So 120 divided by 150 multiplied by 0.7. This will just give us 14 over 25 is just equal to X over 150. If I multiply both sides by 150, this will cancel this, and therefore X will be equal to, X is just equal to 84. X is just equal to 84, guys, ne? So I now know that, okay, I have 84 over there. I have 84 over there. That means for not N, I'll simply say 120 minus 84, and then I'll simply have 36. Remember that, guys, I was given the probability of N, ne? The probability of N is 0.7. So I can simply say the probability of N is basically equal to the number of elements in event A divided by the total number in the sample space. That's just 0.7 number of elements in event n divided by 150, which is our sample space. 0.7 times 150. The number of elements in n is just 105. So I simply have 105 over there. If that's 105, that means I have 45 there, because 105 plus 45 should give me that answer over there. Okay, and then 105 minus 84 will simply give me 21, and then 45 minus 36 will simply give me 9. So now guys, I have filled in the table, so I am good to go. I am good to go now. Okay, we are told that the probability of getting an A in maths is 2x. The probability of getting an A in maths is 2x. That's 2x, and the probability of not getting an A, let's say the probability of not getting an A, that's 3x squared. They want us to calculate calculating how many of your next 15 mathematics tests you will get, rather you will achieve an A. Okay, I know that the probability of A plus the probability of not A is equal to 1, because these two events, guys, are mutually exclusive. Né? It's either on a test you get a distinction or not. Are you together? You cannot be in between. It's either you get a distinction or not. Né? Okay, the probability of A is just 2x. The probability of not A, that's just 3x squared, is equal to 1. All I have to do, guys, is to solve x for me to find the answer over there. Né? I must make sure this equation is in standard form. I'll simply have 3x squared plus 2x minus 1 is equal to 0. And then I'll have 3x, x, 1, and 1. I'll have plus and minus over there. Therefore, x will be 1 over 3, or x will be negative 1, which is not applicable. Why is it not applicable? Because if x is negative 1, that means we'll have a negative probability, which is not true. Probability, guys, is always between 0 and 1. It's a positive number. So x is basically a 1 over 3. Né? So therefore, I can simply conclude that the probability of getting a distinction is 2 times 1 over 3, which is just 2 over 3. And the probability of not, at least, guys, have a 60% chance, but it's still not good. Né? Okay, the probability of not getting an A is just 3 multiplied by 1 over 3 squared, which is just 1 over 3. So now I'm being asked, calculating how many of your next 15 mathematics tests you will achieve an A. The probability, guys, let me use a different color. The probability of getting an A is basically the number of times you can get an A divided by the total number of the coming tests. Né? The probability of getting an A, that's 2 over 3. The number of times we do not know, but the sample space is 15 because there will be 15 tests. Né? Just multiply both sides by 15. So that's this will cancel with that one. Therefore, the number of times you can get a distinction. Oh, shame. Fine, guys. It's 10 times, né? So the number of times you can get a distinction is 10 times out of 15. That's just 10 times out of 15. Guys, you need to pull up your socks. 10 times out of 15. Ha, ha, ha. It has to be 14 times at least. But yeah, to answer the question, guys, you will get an A 10 times out of 15. Né? But I trust you guys. You got this. It will be 15 out of 15. Minus nothing. Bye, guys. Bye, guys. Don't forget to subscribe, like, comment, criticize me on the comment. I like criticism, guys, because it helps me to grow. Né? Criticize me if you have to, but please be respectful though. Bye bye. Subscribe.